the challenge here with COVID is that there's not going to be a one-size-fits-all drug. It's going to be a drug for a very specific population at a very specific time. So many of us, when we think about a virus, we think about the virus, and we don't think as much about the immune response to the virus, but that part of it is just so critical.
You're listening to Epidemic, the podcast about the science, public health, and social impacts of the coronavirus pandemic. I'm your host, Dr. Céline Gounder. David Fajgenbaum's life changed when his mom got sick. His mother was diagnosed with brain cancer when he was in college, and that set him on a path into medicine.
Watching her battle both inspired me to want to help patients like her, and watching her doctors inspired me to want to be more like them. I wanted to dedicate my life towards trying to find solutions for patients like my mom.
David's mom passed away not long after her diagnosis.
That experience for me just put it, very clearly in front of me that, you can do all the right things, you can go to all the right doctors and take all the right medications, and things still don't always work out the way that you would hope that they would.
But that experience only motivated David more. He graduated college and went to medical school at the University of Pennsylvania. He decided to become an oncologist.
And so if you fast forward a few years to my third year of med school, I was, on track and really hopeful about being able to help patients like my mom when out of nowhere I became the patient myself.
That's when his life changed again.
When I was hospitalized, I was even in the intensive care unit, spent almost 6 months hospitalized with liver, kidney, bone marrow dysfunction. I actually even had my last rites read to me.
It took 11 weeks before the doctors could tell David what was wrong. Finally, they figured it out. He had idiopathic multicentric Castleman disease. If you haven't heard of Castleman disease, you're not alone. It's rare. Only 5,000 people or so are diagnosed in the United States every year. But it's deadly.
In the first 3.5 years after my diagnosis with Castleman disease, I nearly died 5 times, and I spent months in the hospital fighting for survival.
Castleman disease affects the body's lymph nodes, but it does something else. It puts the body's immune system in overdrive, especially something called cytokines.
So cytokines are proteins produced by your immune system as part of an effort to typically fight off infections. Those cytokines are actually directly toxic to pathogens, and they also help the immune cells to communicate with one another when they're ramping up their response. But unfortunately, sometimes your immune system can actually produce too many cytokines.
When this happens, it's called a cytokine storm.
And so a cytokine storm is the state where you have very high cytokine levels, and unfortunately those cytokines start causing problems. Your liver, your kidneys, your bone marrow, heart, lungs become dysfunctional because of the cytokines. And so it's what intended to do good actually unfortunately goes on to do significant harm.
Castleman isn't the only disease that sets off these cytokine storms. Many of the most severe cases of COVID are also the result of cytokine storms. There's a lot of hope for what vaccines will be able to do in the fight against coronavirus. But with tens of thousands of new cases every day, there's an urgent need for more effective COVID treatments now. So when researchers and doctors are faced with a novel virus, where do these treatments come from? In this episode of Epidemic, we're going to hear David's story and how his quest for a cure could help us find effective treatments for COVID and other diseases in surprising places. Today on Epidemic, Chasing the Cure. Cytokines are a normal part of a healthy immune system. They work as a kind of communication tool, alerting the rest of the immune system when there's a problem, and then helping coordinate the response. But even when they're doing their job correctly, they can still make us feel bad.
When you get a cold or the flu and you feel unwell, The reason you feel unwell is not actually the virus itself. You feel unwell when you have a viral infection because of the cytokines in your blood that make you feel unwell.
So if we can feel bad from a normal, healthy immune response, think about how this could cause serious trouble if it gets out of hand. Not every person who gets infected with SARS-CoV-2 will experience a cytokine storm, but
in the most severe COVID-19 patients, the ones that end up in the intensive care unit, it's become pretty clear over the course of the last year that these patients are experiencing a cytokine storm.
Normally, when you get sick, your body's immune system jumps into action to fight off a virus or other pathogen. The immune system ramps up, destroys the virus, and then calms back down again.
And for the majority of people who get infected with this virus, that's actually exactly what happens. But for a very small fraction of patients, for reasons that we haven't fully elucidated, the immune system doesn't ramp up fast enough to begin, but unfortunately, it becomes hyperactivated and there's exaggerated immune response.
Basically, it's doing too much too late. David says this slow immune response is more common in older patients.
That's exactly right, because the immune system is just completely out of control, kind of trying to catch up for the fact that it wasn't fighting off the virus early on in the infection.
With something like Castleman disease, the immune system is going into overdrive, but there is no virus to fight.
Any amount of cytokines are bad if there's nothing to fight. And so you can get cytokine storms in the setting of cancer. You can get cytokine storms in the setting of autoimmune conditions. And of course, in neither of those conditions do you need any of those cytokines.
When David was in the hospital, the only thing that stopped these deadly cytokine storms was chemotherapy.
And in the midst of all this, I got an experimental drug. It was the only drug in development for my disease, and we were so hopeful that it would work. But unfortunately, that drug didn't work for me. And my doctor explained to me that I had run out of options, that there were no more drugs in development, there were no more promising leads, and that I really had no reason to be hopeful.
This is a common problem for rare diseases.
95% of the 7,000 rare diseases don't have a single approved drug.
Part of the problem is that rare diseases are, well, rare. There's more incentive and energy to research and develop treatments for more common conditions like high blood pressure, high cholesterol, and diabetes.
Thankfully, drug companies are getting more interested in developing new drugs for rare diseases, and part of the reason, unfortunately, is because they often will charge high prices. So even though the population of patients is small, they can recoup the cost of development by charging high prices per dose.
The chemotherapy worked for David, but just barely. His disease would resurface after several months, and every time David had a relapse, he nearly died. The chemo ravaged his body, and he was approaching the limit for how much of this treatment he could survive.
I was just devastated. But I also, shortly thereafter, within just even a few minutes of my doctor leaving the room, knew that if I was going to hope for all these years for a treatment somewhere, I would need to turn my hope into action. I mean, if I'm going to hope for it to be done, I need to do something about it. And so that was just a life-changing moment for me when I realized that I needed to start searching for a treatment myself.
David got into medicine to help people like his mom. Now he was going to have to use those skills to save himself.
Frankly, I expected that I was probably just, going to go out swinging. I thought that, the best I could do is maybe make a little bit of progress that maybe is going to help someone in the future, but very unlikely that I would make progress that would be enough to help myself.
So with no other options, David took extreme action. He started to experiment on himself.
They had no options. I had no options. There were no alternatives, and there was a real urgency because I likely was going to relapse in the next few months.
We'll hear what happened to David and what it means for COVID treatments after the break. When we left, David was facing down another relapse with no treatment options left. So he took it upon himself to find a treatment.
I had tried every drug that had ever been used for my disease. I mean, my doctors they were the ones who told me that we were out of options.
At this point, his fifth relapse had started. Working with his doctors, David suggested 2 drugs that might help.
I persuaded and talked to my doctors about it. And at that stage, I just barely graduated from medical school. And they thought it made sense to try it. And those drugs didn't work for me. And I got worse and worse.
Once again, David nearly died.
After my 5th flare, I had been collecting samples on myself during that relapse while I was in the hospital and ran a series of experiments. I knew I kind of had one final chance. And so that's when I talked to them about trying Sirolimus.
Sirolimus is a drug that suppresses the immune system. It was originally developed more than 20 years ago as a way to prevent the body from rejecting a kidney transplant. Sirolimus was not approved to treat Castleman disease when David and his doctors decided to try it. Prescribing medications for a disease they were not originally intended to treat is called off-label use or repurposing.
When I started taking it, I was hopeful that maybe I could have an extended remission. I had a wedding date in the future. I was hoping I would make it to Caitlin and I's wedding date. And that's actually all I could really think about was our wedding date was May 24th. So I just needed to make it to May 25th. I didn't really imagine that it could work all that much longer, but that was all I could think about. I made it to May 24th, and then I made it about a year after what was the record at that time for the longest I'd been in remission.
1 year turned into 2.
All of a sudden, we crossed like the longest remission period ever by a day, and it was like, oh my gosh, am I going to cross it by 2 days? Is it going to be 3 days?
7 years later, David is still in remission.
And I remember so well, like the day after my longest remission, so now my new record for longest remission, I just remember my wife Caitlin and I just almost being like shocked, but just so grateful. And really, as every day has passed since then, we're just kind of a little bit more shocked and a little bit more grateful.
Today, David's a physician scientist at the University of Pennsylvania, where he runs the Center for Cytokine Storm Treatment and Laboratory. His office is in the same building where he almost died.
My office was 2 floors directly below the ICU. And I remember just the first time I went in there to be like, oh my gosh, this is now going to be where I'm going to have to work. And that was really hard to wrap my head around. Like, oh my gosh, I have such bad memories here.
But it was actually another person with Castleman disease who helped him make peace with the space.
He was diagnosed within 2 days of getting to Penn. And for me, it took 11 weeks to get diagnosed. And so the stark difference between my experience and his experience, based on some of the things that we had done, and then seeing him benefit and survive and do well, that was a real turning point for me to say, okay, this place, there's some bad memories here, but now we're starting to make good memories. And the good memories have certainly outweighed the bad ones.
He wrote a book about his experience called Chasing My Cure.
Now my work and now my life's mission is to figure out how can we find other drugs like Sirolimus that are already FDA approved that can create 7+ year remissions for other people with diseases that don't have answers, whether it's COVID or many, many other conditions.
David's story may feel far away from the pandemic, but finding drugs to treat a novel virus no one has ever seen before is not so different from trying to find a treatment for a rare disease. A drug that's already FDA approved and been in use for years could be the key to saving lives during the pandemic.
Just because a drug is developed for one disease doesn't mean that it only works for that one disease.
So when the pandemic started, David pivoted his experience with cytokines and drug repurposing to COVID. He started something called the Corona Project in March 2020. It's a database of all the drugs doctors have reported using to treat COVID.
There have been over 400 drugs that have been tried to treat COVID, and the vast majority, over 90% of those, are old drugs. They're existing drugs that are being repurposed for COVID, and some of those drugs are literally saving tens of thousands of lives, drugs like Dexamethasone.
Dexamethasone is a steroid that's been around for 70 years. It's designed to suppress the immune system. It's cheap, well-tested, and if you give it to a COVID patient on a ventilator who's experiencing a cytokine storm, you can reduce their mortality by 35%.
If you give it to all patients who are hospitalized on oxygen, you will reduce mortality by 20%. So this is a huge effect for a $1 a day drug that's been around forever and has well-established side effects.
Fluvoxamine is another drug that's shown success treating COVID. Believe it or not, fluvoxamine was originally developed as a drug for obsessive-compulsive disorder. David's Corona project is working with the FDA to help identify and track these repurposed drugs. The goal is to crowdsource what's working for immediate therapeutic use and eventually randomized controlled trials, or RCTs. A randomized controlled trial is where a group of people with the same disease get different treatments. One group gets nothing, that's called the control group, while the other gets the treatment people want to study. If the patients with the treatment do better than the control group, researchers know it works. But when the pandemic hit, there were no RCTs for COVID.
Early on in the pandemic, there were a lot of decisions that were made based on observational data. So based on the fact that 100 people got one drug and most of them got better, we would then infer, well, the drug must work. But as the pandemic has progressed, we've learned that actually the majority of people get better regardless of what you give them. So just hearing that most people get better when given a drug doesn't mean the drug actually did anything positive.
Randomized trials are the gold standard in medicine, but these can be difficult to carry out in an emergency like the pandemic. There are serious ethical questions like, do you treat someone with a drug even if there's only a slight chance it could help?
It's such a tough question. I think that in normal times, I would definitely say that you need more research in the middle of this pandemic. To have a randomized controlled trial that meets the threshold of significance, that means that there's a less than 5% chance that was just a random result and that the drug doesn't actually work. And so in the middle of a pandemic, and you think, there's a 95% plus chance that this probably does something. It may not be a lifesaver for everyone, but it probably does something in the middle of a pandemic where there's so many people hospitalized. You do have an opportunity, even if it doesn't seem to be terribly strong, to really help people.
But in the absence of data, there are limits to drug repurposing.
COVID has taught us both the good side of drug repurposing with a drug like dexamethasone, but also the downside of drug repurposing, which is that sometimes people can get over-enthusiastic about a drug because it should work conceptually, but then it doesn't actually work when you do the trials.
Like hydroxychloroquine.
One patient was described as Lazarus, getting up after he was like on death's door, and they started getting a protocol of hydroxychloroquine.
Hydroxychloroquine is a very safe drug. It has been given to tens of millions of individuals in the world since its approval.
A couple of weeks ago, I started taking it because I think it's good. I've heard a lot of good stories. And if it's not good, I'll tell you right, I'm not going to get hurt by it. It's been around for 40 years for malaria, for lupus, for other things. I take it.
Hydroxychloroquine was originally developed to fight off malaria, but in the early months of the pandemic, it was touted by politicians and some scientists as a way to curb the cytokine storms COVID can cause.
Hydroxychloroquine is by far the most frequently prescribed drug, despite a lack of evidence. You'll see lopinavir ritonavir is number 2. That is another drug that's had multiple RCTs that have not shown benefit. So there's a real lag between data showing something doesn't work and then kind of us catching up to not prescribe that drug any longer.
But as more data comes in from sources like the Corona Project, medicine can move toward more effective, proven treatments.
These drugs are sitting on pharmacy shelves in hospitals, and they could literally be deployed tonight if a result comes out today. And if they're able to avert 1% of deaths, that's a huge number because of the unfortunate burden of COVID right now. So I really feel very strongly that we cannot pull back. The best thing we can do to save lives in the short term is to keep pushing on treatments and to keep starting up trials, evaluating trials, centralizing data, analyzing data, anything we can do to identify drugs that can avert death from this disease.
When David got sick, he had little information to go off of when he was searching for answers. But the pandemic has reimagined the scale that this search for new treatments can take.
COVID has just been awful in every possible way, but wouldn't it be wonderful, wouldn't it be at least good if we could create a silver lining out of this awful experience where we could use the learnings of drug repurposing, quickly tracking what works, what doesn't work, deciding what drugs should move on to trials, what drugs shouldn't move on to trials with this incredible sense of urgency. But now we just have to figure out how to do it for other diseases. It can't just be a once-in-a-century pandemic because, unfortunately, there are literally thousands of diseases out there and millions of patients with those diseases who have the exact same urgency for wanting a treatment and a solution as all of us do for COVID right now.
Please remember the treatment options we discussed in this episode are not medical advice. If you are undergoing treatment for COVID or any disease, you should talk to your physician first before making any changes. Epidemic is brought to you by Just Human Productions. We're funded in part by listeners like you. We're powered and distributed by Simplecast. Today's episode was produced by Zach Dyer and me. Our music is by the Blue Dot Sessions. Our production and research associate is Temitayo Fajgenbaum. Our interns are Annabelle Chen, Brian Chen, Julie Levy, and Sophie Varma. If you enjoy the show, please tell a friend about it today. And if you haven't already done so, leave us a review on Apple Podcasts. It helps more people find out about the show. Follow Epidemic on Twitter and Just Human Productions on Instagram to learn more about the characters and big ideas you hear on the podcast. We love providing this and our other podcasts to the public for free. But producing a podcast costs money, and we've got to pay our staff. So please make a donation to help us keep this going. Just Human Productions is a 501c3 nonprofit organization, so your donations to support our podcasts are tax deductible. Go to epidemic.fm to make a donation. That's epidemic.fm. And if you like the storytelling you hear on Epidemic, check out our sister podcast, American Diagnosis. On American Diagnosis, we cover some of the biggest public health challenges affecting the nation today. Past seasons covered topics like youth and mental health, the opioid overdose crisis, and gun violence in America. I'm Dr. Céline Gounder. Thanks for listening to Epidemic.